and given to 10 different machines on distributed environment, and now just speak out like how much time will it take for computing? 4.4 divided by 10, what is it? This is the beauty of distributed file system. And here I have shown one slide where you can just imagine in distributed file system, it is not sure or it is not necessary, and it is also not that all systems are in one place. One system may be in the UK, one system may be in US, one system may be in India, one system may be in Dubai, or in any other country's other system. They are distributed all over the globe, but still when a person is working, he feels as if the whole thing is happening on his system only. Here, if you see physically, one is at Chicago, another Houston, another Denver, and another Chicago. But if you consolidate, logically all the systems which are all over the globe are linked, are shown logically at one place. Then again, there is some problem in the system. Then again, that is the distributed system concept, and that is how the entire system works on that. And this Hadoop is purely based on distributed file systems. HDFS, Hadoop Distributed File System. And Hadoop is a framework that allows for the distributed processing of large data sets across cluster of commodity computers with simple programming models. Three things to remember. One, Hadoop is meant for large data sets. Another, it works on commodity computers. And third, it has a simple programming. Very large, as we were saying from the beginning, big data means huge data with a complex computation. So very large data sets. Second point on commodity. Like for example, if you want to make a cluster of 300 computers, and those 300 computers are not some special computers on which you are setting up that 300 computers will cost in millions. It's not like that. Your day-to-day laptops, which will cost you hardly 40-50,000. In fact, not 40-50,000. In fact, 20-30,000, 20 or 30,000 these days. They are called commodity machines, which you are using day-to-day. Hadoop file system doesn't use any special machines. They want commodity machines, day-to-day life machines. That is why Hadoop system is very cheaper in cost. It's very cheap. And the other aspect is very simple programming. Remember one point which is very important. Please remember, this is the most important point in Hadoop system compared to other distributed file systems. In every distributed file system, whether it may be peer-to-peer, whether it may be shared memory, whether it may be client-server machine, almost in every distributed environment, what did we notice? Data is moving in the network. Data is moving in the network. And we all know, movement of data in the network is very expensive task. Very hectic, very insecure, and also very costly, expensive. But the beauty of Hadoop, data don't travel in the network. Data is only on the machine. Once kept on machine, that remains on same machine. Computation takes place based on the map code. Map and reduce. We have seen what is map and what is reduced. When map and reduce is working, the concept or the code of map is shifted to the servers or shifted to the commodity system on which the computation has to be performed. I repeat once again, the most important aspect seen or most important advantage also we can term in Hadoop is Hadoop doesn't allow travel of data in the network. Data is on the machines. Wherever computations has to be performed, only map code is transferred to that particular machine and computations takes place. And the size of map code is some kilobytes. Simple programming, that is what is shown in the last point, like simple programming model. You don't have to do any complex computations. You have only to do a simple programming that is within kilobytes of data which will be based on, and just push the data to the commodity systems and you can start working. Here I want to make you 2 points. One is it is very beneficial because of it is very easy to work. It is very easy to work because of simple programming. Another aspect in entire Hadoop systems, all the researchers or the people who are working on that, they have to mainly concentrate on map reduce concept. The best map you design, the best work you can perform. So the entire improvements are coming in the field of map reduce only. So research is more focused in the big data, particularly in Hadoop systems. More focus is map reduce. And these are some of the companies which are using big data analytics, Yahoo, Google and so on. These are some major companies, but near future there will be situation where even other day-to-day company will also start using, because there is drastic difference in the drastic improvements are coming in the companies which are using big data analytics. They are more fetching the benefits, they are more profit oriented, they are gaining lot of profits due to this big data. So naturally wherever there is profit, their business people try to switch. Hadoop core components are based on 2 things, that is, one is map reduce and another is HDFS cluster. HDFS cluster is for storing data, and map reduce map reduce is for computing. I will clarify a doubt in the break because we are left out with a very small duration. Map reduce is for computations and HDFS is for storing data. And they have some more important components, naming as name node and data node. Name node is only one in entire system, and data nodes can be millions of data nodes. And there are 2 more concepts, that is job tracker and another is task tracker. Job tracker is something which keeps track of all the jobs. For easy understanding, I will go in some detail. Like if you have one, you can just imagine this in master-slave architecture. Name node is master and the data node is a slave. And slaves can be any number. Name node is only one. Data nodes can be in million. If there is a file which has to be computed, that file is logically split into modules and sent to different data nodes for computation. But name node is that node which keeps track of all the pockets of data or the blocks of data which is being passed in the network. Data X block is located in so and so data node. Y block is located in so and so data node. This entire index of entire thing is placed in the name node. So you can imagine that job tracker is something which tracks of all jobs. Fine. And task tracker is related with the task which is being performed in that particular data node. Hadoop distributed file system. It has some of the features. First feature is highly fault tolerant. We are mostly concerned about losing of data, is it? We remember that we can never compromise in data, isn't it? If anybody, like there was a TV show, in that they were just showing, we'll give you a new laptop with highest configuration of the company. Would you like to exchange your laptop with this laptop? No one agreed. The only reason for everyone is we don't have backup of our information in our laptop, and at this particular spot we cannot exchange it with you. What is the meaning of this? Laptop, the hardware part is not important. What is important is data, which is in that hardware. So in that situation, data is the most expensive and most important thing, and that cannot be we cannot give any chance of losing that. Because of that, Hadoop has taken care of that and made itself as a fault tolerant. How did it do? What do we do in Hadoop that it became fault tolerant? We make replica. For every data, we make 3 copies. If one system fails, then other 2 systems are there. In this way, we manage, and never it happens that all 3 systems fail. Here one point should come up. Sir, when you are making 3 copies of every data, will it not become very expensive? Certainly, it becomes very expensive only if you are using high configurations and high feature computers. But we are not doing that. We are just using commodity computers. So here there is no point of becoming expensive in the network when we are considering fault tolerant feature in this. Second one is high throughput. In high throughput, what we are doing is the speed of reading the data is very high. I will be showing you in detail how the speed of reading is very high in my next slide. And the third one is, this is suitable for applications with large data sets. It is never correct to use small data sets on Hadoop. It is meant for very large data sets and streaming access to file system data. Write once and read many times. And at the same time can be built out on commodity hardware, just to put the entire network, entire system on a very cheap level. This is the same thing, particularly the definition is given, and at the same time there are 2 important components, that is the name node and the data node. Where HDFS is not that good to fit. One thing is low latency data access, where one feature to be read in a file, whereas HDFS is good in reading the entire file in one shot. And at the same time, there is another point, like lots of small files. I always keep stressing that large data sets to be used. So here lots of small files are there, that is not preferable. Multiple writers and arbitrary file modifications, even these are not that good. And importance of name node and data node. When we talk about name node, it is something like master of the system, and it maintains and manages the block where are present in data node. As I said, that job tracker, it keeps track of jobs. Which job is located in which place. So another is data node. Data nodes can be in millions. They are like slaves in the network, and they are responsible for serving read and write requests for the client. Another important aspect in Hadoop, that is client. In the whole slide, the only thing which is new for us is client. What is client? Client is a user who wants to inquire where is his data. He has the ability to interact with the name node as well as data node. here is the architecture. You have some very important aspects. One, you can say the name node. You know what is name node, what I have just discussed a couple of times. And the other point comes with metadata. What is metadata? Data about data. Data about data. Like, what is the address of the data? It is some information related with that particular data. And on which data node this particular data is. All these things are related with data. So we call it as data about data. And this metadata is placed in the RAM of name node. For fast access, we put it in the RAM of name node. Then another point we can see data node here and data node here. So 3 systems here and 2 systems here. And another, just now anyway we have seen what is client machine. And when we talk about this rack 1, rack 2, what do you mean by rack? These are normal networks terminology. Some storage place where you put your storage, where some storage place where you can put your machines. And here we are speaking that there will be replicas. So there will be some replicas. Like we create 3 copies of each data. And so data block ops. What is block ops? Some we know that large data will be split into blocks. You know what is the size of block?
64 MB.
64 MB to 256 MB. It can vary. You can make it a block of 64 MB and you can go up to the range of 256 MB. So this is how. And one important aspect in this particular slide is like how the data is getting split. Your communication is such that like the user is copy input files and again he submits. Once he submits, it gets the file, input file information, and based on the input file, the system predicts like logically how it can be split, and it splits. Then after splitting, each block is passed in the network. Each block is given to a data node, is it? So in the architecture we have seen that these are the data nodes. All red color blocks, all red color boxes are data nodes, and there are some yellow small boxes where the data is coming and residing, just for understanding purpose. Then again, here you can see that a large input file has come, and logically the machine has analyzed in how many parts it can be split, and the entire large file is split into number of small blocks that may range from 64 MB to 556 MB. Then here the very important aspects, these input splits will be given to the task, will be given to the machine, and it is always seen that if, for example, n number of splits are there, then the job tracker will decide that when, for example, job tracker will decide if 10 splits are there, then 10 map code has to be generated and sent to that particular code. Fine. This point, if 10 number of splits are there, if 10 number of blocks are there, and they are passed in the network to 10 different data nodes, based on number of modules or splits, job tracker will decide how many map code has to be generated, because the data is not traveling in the machine, in the network. Map code is traveling. So if 10 blocks are there, 10 map codes are generated, and those 10 map codes will go to those 10 blocks and perform the mapping process. So here is one, and this is related with here. What do you see the new term here? Heartbeat. In the network, wherever the data nodes are there, they keep giving heartbeats. Like they will be giving a signal to the name node. We are active, we are alive, and we are ready to take some more blocks of data. Based on that particular heartbeat, the data will be assigned to data nodes. Here it is shown particularly how the task tracker works. Like in the task tracker, these are related with the map and these are related with reduce. One thing to be remembered here is number of map can vary and number of reduce codes can also vary. And how to create a new file. How to create a new file. I was telling you in the very beginning, user has the ability to interact with the name node as well as data node. So that the scenario is shown here. Whenever a user wants to create a new file, user just sends a request to the name node that I want to create a new file. The name node indicates to the user, sends an acknowledge stating that that data node is available. You can go and create the new file. Then the client will push the data directly to those particular data nodes. Very important point. Name node doesn't assign data to the data nodes. Name node only specifies which data nodes to be used for pushing that particular data. It is the user who will push that data to those particular data nodes. Second point to remember, the pattern of pushing the data is not just randomly pushing the data in the network, but when 3 data nodes are used for each block, so data comes from the user and goes in pipeline process like this. Data, when it comes directly from this data node, it goes to this data node, and from this data node it comes here. Then second second block stops here, and the third data packet stops here. They go in pipeline. Two things are discussed here. One, user interact with name node and find out where to push the data. After getting the information, user himself pushes that particular data to the data nodes. And that pushing of data or assignment of data is not just like this, but it is in a pipeline process. Coming to see like file write, how do we write a file? As just now I have discussed, first user, the first HDFS line, that is nothing but user, will push a command, create, and when that command is pushed to the name node, it indicates, it gives the information where it has to be, where it has to push the data. Then from the client side, the packets goes to the name nodes and comes to this point 1, then to this, then to this, then comes back and says it is over. When it closes, it gets an information that the whole process is completed. The whole process is completed. The user is first asking the name node that I have to create. Then the name node is instructing, yes, you can create and you can follow these 3 nodes, data nodes. Then it is pushing the data to those 3 data nodes, and finally acknowledging the name node, that the process is over. And again you can see a process of pipeline is being followed here. And when this is for writing, and let us see how it is read. Same, the client is pushing his command and get block locations. Now it want to find out where the particular data is in the network. The name node specifies that this, the data about your inquiring data is present in so and so block, data nodes. So based on that information, the client tries to access those data nodes and fetch that data nodes in parallel. Important point here is, while writing the data, it pushes in pipeline. But while accessing or fetching the data, that act parallelly. Why? Because if there is a failure in system, there is no waste of time. If one is failed, then other two will send the data. If two fail, then third will fail. Now you don't ask if third one fails, what will you do? It is something like sitting with a helmet in a hall, getting that a fan fall at any time. So little risk is always. So safety measure, three aspects are taken. And while reading, while fetching the data back, all three are read parallelly. This is some of the things. And how do you allocate the data? As it was said, like you have block A with a red color, and you have 3 racks, rack 1, rack 2, rack 3, and you have data nodes here, data node 1, 2, 3, 4, and likewise all this. Where this block A will go? Where then can this block A can go? Simple, anywhere. Everywhere it's free, is it? It's free to go anywhere. Entire racks are vacant. So it comes here. Another may come here. Why 2 in same rack I mentioned? Because it can be in 2 data nodes. The reason is, if one fails, another is there. And failure is very less. Failure rate is very less. So need not worry much. Then again block B, then block B are other 2 copies, then block C, then block C other 2 copies. One thing you might be observing, only two data nodes are rack is being followed, but they can be on 3 different racks also. No issue. Till now you have seen theory part. I will show you a very beautiful example which will give you double strength on your confidence level. It will give you a double strength to your confidence level. Only the condition is, watch the example very carefully. Fine? It's just a matter of 2-3 minutes. But if you watch the example, your confidence level will boost up like anything. You know what is MapReduce? Is it? Yes, let us. You know what is this was thing we discussed about data node, and these are the name node, and these are the different data nodes. Then I went on stressing on the point, data is not transferred in the network. It is very expensive and it is also very risky. We cannot compromise in the fact of data. In that situation, HDFS only transfers map code rather than data, and map code is some KBs. See here. This is map code, and that is just the code is there, and these are some of the data nodes. These are some of the data nodes, and this is a map code. What it does, it will not pull one after the other like this, but It just goes, the map code goes to the data node and perform its operation. Fine. Then generate some reduce path. Normally we say that map reduce means only two parts, but it's not just two parts, but every map and reduce in between there are a couple of operations like combiner is there.